Hey, welcome to my video on Innovation Hour, and today I'll be talking about the science of temperature. Now, the science of temperature, it's not really simple, it's very hard to explain, but I'll try to do the best I can. So coming up on this whiteboard, you can see something that you already know. Ice is very compact. You probably know that if you put ice in a container and you let it out on the counter for a little bit, there seems to be more water in the container that there originally was. And that is because colder objects, the molecules, compact. They're a lot closer together. There's not as much space in between them. But something like water vapor, it's very spread out. The molecules are kind of all over the place, which probably has something to do with the fact that you cannot see it. That goes with all particles. The colder, the more dense the object is, and the warmer the object is, the less dense it is. Think about temperature outside. You learned this in science class a little while ago. The molecules are closer together. There's higher pressure when it is colder outside. So that leads me to a question of, well, if objects can get super dense, shouldn't there be a point where the molecules can't get any closer together? Well, that's correct. That is called 0 Kelvin, also known as the coldest possible temperature in the universe. So in a second we're going to transition to the next slide. Just a few interesting facts on temperature, which is probably will make up most of my video. 0 degrees Kelvin is the coldest possible temperature in the universe. As I stated earlier, you gotta get colder and colder because the particles are gonna move closer together, but there is gonna be one coldest temperature, and this is absolute zero, or 0 degrees Kelvin as it is called in science. So you may ask, why cannot 0 Kelvin ever be reached? Well, it has to do with, the property of particles. If you think about, you got a cold glass of water in a room temperature room, that cold water, it's not going to stay cold forever. In the same way, 0 Kelvin can never be reached because of this property. There's always going to be a warmer object with a higher energy state that's going to come in and even out with these particles and change, this object from 0 Kelvin to another temperature, because this property happens instantly. 0 Kelvin, therefore, can never be reached. The third one, particles, they like to take on lower energy states, actually. It's easier for them to remain a stable configuration while maintaining a lower energy. The higher the energy, the more your electrons are just buzzing around, and it's harder for the particle to, keep control. So therefore, the lower the energy, the more stable, typically, the element is. So this is more when science and temperature gets extremely weird. So they can actually have negative temperatures. It's when the particles favor higher energy states versus lower energy states. So negative 0 Kelvin would be, instead of 0 Kelvin, where they all maintain the lowest possible energy state, negative 0 is where they all have the highest energy state. So the picture on the left is 0 Kelvin. They have no energy. They are all very compacted together, and they are at the bottom of the hill. Infinite temperature, which is in the middle, infinite temperature, despite what you think is the hottest temperature, it's not. It is when all particles have distributed all energy states equally. So the picture there actually is a good explanation of it. All particles are equally likely to be at the top of a hill and the bottom of the hill at the same time. Negative 0 Kelvin, because they all have higher energy states, they actually cannot go down the hill. They would favor the top of the hill versus the bottom of the hill. It's very confusing. I honestly don't get it either, but it's because you cannot reach really negative temperatures anywhere except in a lab. So you wouldn't see a ball on top of a hill not rolling down like this on a normal day. Thank you for watching my video. I will put a link in the end of the video. That will lead you to a website that I got most of my answers from. Give a lot of credit to that website. Hope you learned something today, and thank you for watching.